Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'm going to title it how I title in the title. But what I am sure of are 3 goals for the day. Our first goal is going to be to solve one-step inequalities using multiplication or division. Our second goal is going to be to answer this solution. And our third goal is going to be checking. Now right here I just have a little bit of a review of what the symbols mean. This symbol means left of and it's an open circle. This symbol means left of and it's a closed circle. This symbol means right of and it's an open circle. This symbol means right of and it's a closed circle. Remember, closed circles are shaded in and solutions are the shaded part of the inequality. So the nice part about this lesson is we're using an idea from solving equations. So to solve one-step inequalities using multiplication, we use step 1 from the 1 through 6. And that's going to be to eliminate fractions by multiplying everybody by the denominator. So we already know how to solve using multiplication. We also know how to solve using division, and we use step 6, which is divide away the number on the variable side of the equal sign. But we don't have equal signs, we have inequality symbols. Alright, so I have a couple of examples of solve, graph, and checking, and both of these are actually solved by multiplication. Okay. Alright, solve by multiplication. So again, eliminate the fractions. I eliminate the fractions by multiplying everybody by the denominator. So in the first problem, the denominator is 5, so I'm going to multiply everybody by 5. I have one number on the left, one number on the right, so each number gets a 5. The 5s on the left cancel, and I'm left with x is greater than 15, or the shading is right of 15. The shading is right of 15. Alright, so I'm going to draw my inequality. I'm going to put a 15. My circle must be open because I have that row. So it's open at 15, not part of the solution, and I shade to the right of 15. Remember when I check, I pick a value that's in the shading. Now, some of us just might want to pick the next number we see, like 16. The problem with picking 16 is 5 does not divide 16 nicely. We can still use 16 though, so I'll show you how we can do that. So if I was to pick 16, and I'm going to plug it into my original inequality, so wherever I have an x, that becomes a 16. So now I have 16 divided by 5. Is that right of 3? Well, just like we eliminate fractions when we solve, we can eliminate fractions when we check. And so what I can actually do here is multiply everybody by 5. So 16 over 5 is considered one number, so it only gets one 5. 3 gets a 5. Those 5s cancel. 16 is right of 15. Is that a true statement? Well, guess what? We can see right here, 16 is on the right of 15, and that is true. So we've shaded in the direction of the solution. So any number going this way will be a solution to that inequality. What's going to happen is the further out we pick numbers, the further the further right these numbers become to 15. All right, let's go ahead and do the second one. So again, I'm going to solve by multiplication. I have a fraction, so I must multiply everybody by the denominator. So everybody in this problem is multiplied by a 4. You get a 4. And you get a 4. Well, the 4's on my right cancel. So now I'm left with x. 4 times negative 6 is negative 24. So that means that negative 24 is right of or at the shading. Negative 24 is right of or at the shading. Okay, so let's see here. I'm going to put a negative 24. Since I have that symbol, that means that my circle is closed or shaded in. So I'm going to make sure that's very clear that it's shaded in. And this is on the right of the shading. So if I shade this way, negative 24 is on the right side of that. Okay. So I've graphed it and now I need to check it. So I can pick any number. The shading, let me just put a 0 here to help you understand that these numbers going this way are going to be larger. Now on this example, I just picked the next whole number in the shading. On this example, I'm going to pick a number that divides nicely by 4. So it looks like the next number that's going to divide nicely by 4 is negative 28. So I'm going to plug negative 28 into my x value and we're going to see if this is true. Alright, so I get negative 6, is that to the right of or at negative 28 divided by 4? Well, 4 goes into negative 28 negative 7 times. So negative 6 is that right of negative 7. Right? So let's look at a number line here. I got my 0, I got my negative 6, and I got my negative 7. Negative 6 is right of negative 7, so this is true, and I have shaded in the correct direction. So I wanted to actually split this lesson up into 2 parts. I wanted to solve by multiplication because I do want to talk a little bit about a special circumstance when we divide by a negative. So let me clean all this up and I'll be back. I'm back, so are the crickets. Okay, so I'd like to investigate what happens when you divide by a negative. So the next set of problems we're going to divide by a positive, we're going to divide by a negative. But I want to make it very clear what happens when we divide by a negative so we understand why we have to do the following move. Only when we divide by a negative. So let's investigate what happens when you divide by a negative. So right here, I'm just going to compare 5 and 6, compare their positions, or describe their positions. And I can say 5 is left of 6. Right? 5 is on the left side of 6. Or if I was to write it mathematically, 5 is less than or 5 is left of 6. Alright, now, what I'm going to do is I'm going to divide both sides of this by negative 1. Well, I have my 5 left of 6. I'm going to divide that by negative 1. I'm going to divide that by negative 1. And now I have negative 5 and negative 6. Alright? I want to put these on a number line and see what happens. So I had my original 5, I have my original 6, there's my 0. Now I have my negative 5 and my negative 6. Alright? So originally 5 was on the left of 6. But when I divided by a negative 1, I actually changed the signs. And when you change the signs of numbers, you change their position. Alright? So that means now that negative 5 is on the right of negative 6. And again, it changed its position because we changed the sign. So when you divide by a negative, you change the signs of your numbers. When you divide by a negative, you change the signs of your numbers. So I went from positive 5 and 6 to negative 5 and 6. So when you change the signs of your numbers, you end up switching the position of the numbers. And so you go from being on the left to on the right, or on the right to the left. So let me summarize what we need to do. And I apologize for this boring writing that you get to watch. So, and by switching positions, I mean they go from the left to the right. So when we divide by a negative, the numbers switch positions. which means we have to change how we describe their position. So what that means for us is to solve using division, use step 6. Divide away a number on the variable side of the inequality symbol. And if we divide by a negative, we must switch the inequality symbol. And if we divide by a negative, we must switch the inequality symbol. Only if we divide by a negative. Alright, so I'm going to go ahead and pause it here, set up a couple examples of solving by division. We'll have one when we don't divide by a negative, and we'll have one when we do divide by a negative, and I'll show you how we do this step. But again, when you divide by a negative, what you're doing is you're changing the position of the numbers on the number line. So this was on the left, now it's on the right, because we changed the sign. So let me clean all this up, and I'll be back. I'm back for the last time, I promise, and the crickets are back too. They just come back when I'm about to start this. Alright, so we're going to solve graph and check, and for these problems we use division. So in the previous section, I was hoping to convince you that if we divide by a negative, we must switch the inequality symbol because the position of the numbers switch, and so we have to just change how we describe the position. So what was on the left is now on the right, or what was on the right is now on the left. Alright, so let's look at step 6. Divide away a number on the variable side of the inequality symbol. And if we divide by a negative, we must switch the inequality symbol. Well, I know that I can't add or subtract away this number because there's no plus or minus between it. So that means that I must divide away the 3. Now, I'm not dividing by a negative, so I don't need to switch this. So my 3's are going to cancel out. And that means that the shading is right of or at -4. I divided into a negative, but I didn't divide by a negative. So the inequality symbol does not switch. So the shading is right of or at -4. So let's go ahead and draw that. The shading is right over at -4. I have a circle that's closed, which means I shade in, and I shade to the right. I can pick any number I want. And you know what? I'm going in the direction of 0. I like plugging in 0 to check, because that's the easiest number to work with when you're multiplying by it, or adding to it, or subtracting. So here I have 3 times 0. Is that on the right side of -12? Well, 3 times 0 is going to become 0. And is that on the right side of -12? Well, there's 0. -12 is out here somewhere. And this is true, so we have a solution. And we did have a solution because we didn't switch that just because we divided. Students want to switch it when they divide, but we don't need to switch it. We only need to switch it when we divide by a negative. Twisted my tongue. Alright, problem number 2. There's no fraction, I can't do step 1. There's no plus or minus sign in there, so I can't use addition or subtraction. So I have to use division. Now, in this problem, I must switch the inequality symbol because I'm divided by a negative, which means I'm changing the position of the numbers, so I must change the description of where they're at. A negative into a positive is a negative, and that's, the shading is right of -4. I did not mean for this to have the exact same answer as the previous problem. Well, no, it's not the exact because it's an open circle. This one, that's a solution. This one, the -4 is not a solution. Right, so there's my -4, is right of -4. Okay, so there's my -4, shade to the right. And guess what? I am going to use 0 again because 0 is a number that's in the shading, so I'm going to check it. Okay. So I have my -4. I'm going to times that by my 0. And is that left of 16? Well, -4 times the 0, that's a 0, is 0 left of 16. Well, way out here is 16. Way up. And this is true. 0 is left of 16. So that means that I've shaded in the right direction and I have a solution. So let's just do one more example together. Call it a day. Alright. And the only difference with the third example compared to the second and the first is the variable is on the other side. And let's just, again, go through this. I can't eliminate fractions. There's no plus or minus between the 2 and the x. So that means I must divide away the number. It's not a negative number I'm dividing by. It's just a positive 2. So there's no need to switch the inequality. So the 2's on this side cancel. I gotta cancel these out. I gotta make a habit of that. 2's on this side cancel, and 2 goes into 16 18 times. All right, 8 times. Learn your math. All right, 2 goes into 6 8 times. All right. So now I'm going to translate this, which means 8 is right of the shading. All right, so I'm going to draw my graph. It's open circle at 8. And if I shade on this side, 8 is on the right of the shading. So I've done that correctly. And guess what? 0 will be in the shading. So I will check 0. It's a great number to check. So I go back to my original problem. 16 is right of 2 times 0. Well, 2 times 0 is 0. Is 16 right of 0? Well, 0's over there, 8's here, 16's way over there, so 16 is right of 0 is true. So we've shaded in the correct direction. Alright, so hopefully you understand how to solve one-step inequalities using multiplication or division. Again, a little bit extra practice, but what was important, we saw that if we divide by a negative, we must switch the inequality symbol. Now, technically, if your fraction problem has a negative in the denominator and you multiply both sides by a negative, you also must do this. But in my class, I will not have that situation for now. So I'm going to go ahead and end this lesson here. Again, I hope everybody is doing all right out there. Have a great day, everybody. Bye-bye. Bye-bye, cricket.